multiply 3 times the fraction 2/3. All right? Now, you would look at this and you would probably say, I have no idea how to do that. But then you should remember something from a previous lesson that we have discussed. And that is that any whole number that you have, whether it's 3 or 5 or 7 or 10 or anything else, you can always write it as the number divided by 1 or the number over 1. Because fractions, this is a fraction here, is really also represented by division. We talked about that many times before. So if you want to represent the number 3, you can always write it as a fraction, simply 3 over 1, because that's 3 divided by 1, which is just 3. So this, the number 3, and this, the fraction 3 over 1, is exactly the same thing, because this is like division here. 3 over 1 is 3. All right, so we're still multiplying by 2/3, and we want to show you how do we calculate that. So I said before, when you multiply fractions together, and also you'll learn later when you divide fractions, you do not have to worry about a common denominator. So it's actually easier. These denominators are different. You have a 1 and you have a 3, but that's okay. All you do to multiply fractions is you do 3 times 2 on the top, we multiply the numerators, and 1 times 3 on the bottom. We just multiply the denominator. So on the top, you will get 6, and on the bottom, you will get 3. That is the answer, 6/3. But you have to ask yourself, is this simplified? You always check your fraction when you're done to see if it's fully simplified. In this one, we have a 6 over 3, so we can try to simplify it, but then we realize this is the same as 6 divided by 3, and 6 divided by 3 is 2. 6 divided by 3 is 2, and 2 is the answer. So you might ask yourself, well, how is it you take 3 times a fraction and what you get at the end is just a number? Well, think of it this way. We know that you can multiply regular old fractions by numbers, and you can sometimes end up with numbers. For instance, if I have half of a pizza and I multiply that times 2, what do I get? A whole pizza. Let's show you how that would work if we're actually going to do that problem. If we have 2 times 1/2 of a pizza, how would we do that? Well, you know the answer is 1 whole pizza, but let's show how you do it with the math here. And the way you do that is the 2, you just write it as 2 over 1. We're still multiplying 1 by 1/2. All right? And then what you do is you multiply the numerators, 2 times 1, and then the denominators 1 times 2. So what you get over here on the top is 2, and on the bottom you also get 2. And if you remember, 2 divided by 2 gives you 1. So you know from your experience that 2 times 1/2 of something should give you a whole pizza or a whole peanut butter and jelly sandwich or whatever it is you're talking about. This is how you do it in terms of the math. So that's how you can get this in this case. If you measure 2/3 of a pizza out, and you take 2/3 of the pizza from one box, and then 2/3 of the pizza from a second box, from a second pizza, and then 2/3 of a pizza from another box, and you arrange all of those slices together, you're going to end up with 2 whole pizzas. It's the same exact concept. The fundamental key thing here is to remember that when you are multiplying a fraction times a whole number, you write the whole number over 1, and then you multiply the fractions by multiplying the tops, multiplying the bottoms. So let's get some more practice with this. What if we have the number 12 times 1/3? 12 times 1/3. Well, the first thing we want to do, we cannot multiply these unless we're multiplying 2 fractions. So we represent the 12 as 12 over 1. We're still multiplying by 1/3. All right, now up here, we end up with 12 times 1 on the top, and on the bottom we end up with 1 times 3. And so on the top, 12 times 1 gives you 12. On the bottom, 1 times 3 gives you 3. And you try to simplify this, but then you realize I can divide this. 12 divided by 3 is going to give me 4. So the answer is just 4. So far, for every time we've multiplied a fraction by a whole number, we've always gotten a whole number back. But that's not always the case. Let's do one when that's not the case. What if we have 2/5 times 5? Now here we've had the whole number times the fraction, whole number times the fraction. Here we have it backwards, the fraction times the whole number. But you do exactly the same thing. I mean, there's no difference. You write it as 2/5 times, and then the 5 becomes a 5 over 1. You always write whole numbers as fractions. And then what you have is 2 times 5 on the top, and here you have 5 times 1 on the bottom. You do not have to worry about getting any kind of common denominator to multiply fractions. what you'll get on the top, 2 times 5 is 10. On the bottom, you will get 5 times 1 is 5. And this is one of those cases where you're going to get a whole number. 10 divided by 5 is going to give you 2. 10 divided by 5 is going to give you 2. Now let's do one where when we do the multiplication, we don't actually end up with a whole number at the end. All right, let's say we're doing the fraction 3/5 times 4. All right, and we want to multiply this. So the first thing we do is we write 3/5 times, and we write the 4 as 4 over 1. So now we have a fraction times a fraction. So then we multiply the tops, 3 times 4. We multiply the bottoms, 5 times 1. And what we get on the top, 3 times 4 is 12. And on the bottom, 5 times 1 is 5. So that's the answer, but we always try to simplify it. The first thing we look for is we say, can we say 12 divided by 5? Well, it doesn't really divide evenly, so we can't get a whole number as we have for the other fractions. Secondly, we try to simplify it. Can we divide top and bottom by any single number to make this simpler? And we can't do that either. We can't divide by 2 or by 3. For both of these guys, because we have that pesky 5 on the bottom, that's not going to let us do that. So basically, you could circle this as the answer, but then we also realize that this is an improper fraction. All right, and we can always convert improper fractions to mixed numbers. How many times will 5 go into 12? Well, it'll go 2 times, because 5 times 2 is 10. Now, the difference between 12 and 10 is only 2, so that's the remainder, and we write it over the denominator, which is 5. So the answer that we get from this multiplication can be written as an improper fraction, 12 over 5, or you can write it as 2 2/5. They both represent exactly the same thing. Because, you know, mixed numbers and improper fractions, we can always switch back and forth. Okay? Now what if we have 2/5 times 12? We want to do that one. So we have the same sort of thing. We take 2/5 times 12 over 1. We write the whole number as 12 over 1, 2 times 12 on the top, and 5 times 1 on the bottom. Now, if you remember from your multiplication tables, 12 times 2 is 24 on the top, and 5 times 1 is 5 on the bottom. So you get 24 over 5. So we try to simplify this, and we really can't divide it 24 over 5 evenly, and we can't really pick a number to simplify the fraction, so we could circle it like this. But then we also realize that this is also an improper fraction, so we can convert to mixed numbers. So 6 times 5 is 30, that's too many times. 5 times 5 is 25, that's too many times. 4 times 5 is 20, so this can be divided into there. 24 divided by 5 can go a whole 4 times. It gives us 20. The difference between 24 and 20 is 4, and we always write it over the bottom number here. So we get 4 4/5. If you're having problems converting from improper fraction to mixed numbers, then go back to some of the previous lessons in the 5th grade series. We have a lot of practice with how to go back and forth between mixed numbers and improper fractions. So when I circle both of these answers, basically you can write it either way. You're getting exactly the same answer. All right? Now, I have a couple more just to get a little more practice. What about the number 1/6 times 3? Well, the way we would write that is 1/6 times, we'd write the 3 as 3 over 1. And then we multiply the numerators. 1 times 3, and then 6 times 1. All right? And so then if I switch colors here on the top, I'm going to get 3. 1 times 3 is 3. On the bottom, I'm going to get 6. So you could say that that's the answer, but then we realize right away, we try to simplify it. This is not an improper fraction, but I can simplify this by dividing the top by 3 and also the bottom by 3. So 3 divided by 3 gives us 1 on the top. 6 divided by 3 gives us 2 on the bottom. And so you get 1/2. So this is the final answer, 1/2. If you take 1/6 of a pizza and you do that 3 times from 3 different pizzas and arrange them together, what you actually have at the end of the day is half of a pizza if you arrange all the slices. All right? The final problem we're going to do in this set here is 2/7 times 2. 2/7 times 2. So what you do is you keep the fraction 2/7, and you write the whole number as 2 over 1, and then you multiply the numerators, 2 times 2, and then you multiply the denominator, 7 times 1. And what you will get when you do both of those things, on the top, 2 times 2 is 4, and 7 times 1 is 7. And so you look at this and you say, can I simplify it anymore? And the answer is you really cannot. 4/7 is the final answer. I cannot divide top and bottom by anything to simplify that. It's also not improper, so I can't really do anything with that. So this is the final answer.